Okay, guys, welcome to the post-contest discussion. So I guess we can start discussing the problems now. So what is the first problem? Let's read and try to understand. Okay, the problem is least product. You are given an array of integers a1, a2, an. Now there are there is an operation that you can do, and you can do it any number of times. Okay, so if the value of the element is ai, you can change it to any value from 0 to ai. And if ai is negative, you can change it to any value from ai to 0. Now, first we need to find what is the minimum possible product. And after that, we need to find what is the minimum number of operations that we need to make this product. So this question might seem hard, but after thinking for a bit, you will understand that, okay, it is not that hard. Okay. So now let's consider some cases. Okay. Let P be the product of the array. What can P be? It can either be smaller than 0. It can either be greater than 0. Uh, and it can be equal to 0. Okay. Basically, what I'm saying is it can either be negative, it can be positive, or it can be 0. So now let's take this case. Okay. When the product is 0. If the product is 0, what does this mean? It means that one of the elements is 0, right? Only when one of the elements is 0, the product can be 0. So if one of the elements is 0, can you change this 0 to anything else? You can't, right? You can only keep it as 0. So whatever you change the other elements into, for example, let's say there was a 10,000 also here, or let's say a minus 10,000 also here. Even if you make it 1 million or 10 million, whatever, the product will always stay 0. So if the product is 0, then we can say that, okay, it is always going to be 0. So there are no operations that we can do. So it will just be 0, right? Because it's already the minimum. Now, if the product is positive, what can we say, guys? Okay, product of the array is greater than 0. This means that there are even number of negatives, or there are no negatives, or and there is no 0. Okay. Now, is this much clear? Like if the product is greater than 0, there are either even number of negatives, because let's say -1 into -1, this will give us 1, right? But -1 into -1 into -1 will give us -1. So only if there are like even number of negatives and then some positives, or there are no negatives in the array, or and there is no 0. This is for sure. Otherwise, product wouldn't have been greater than 0. Now, if there are even number of negatives, what can we do? We can only change the sign of the product. For example, let's say it is -1 into -2 into -3 into -5. Okay. Now, if I just, and let's say there is a 5 here. Okay. And let's say there is a 6 here. Now, can we make this negative? Can we make this product negative, guys? Tell me. Why cannot we make this product negative? There are even number of negatives and there are some positives. There is no 0. Can we make this negative? Exactly. So this will only be negative. Okay, this product will only be negative if I can convert one of the positives into a negative, or I can convert one of the negatives into a positive. Now, what am I allowed to do? For any positive, I can, let's say the positive value is x. I can only change it from 0 to x. I can change it to any value in this range. And let's say for the negatives, I can change it to any value in the range 0, x to 0. So can I really change the sign? Like if this is 2, is it possible to make it plus 1 ever? It is not, right? So if the product is positive, the first observation is you can't make it negative. You can only make it at most 0 if the product is greater than 0. Now, if you want to make the product 0, what do? You just take any one of the elements and you do a 0 operation on it. That is, you make it 0. Is this much clear, guys? Okay. Now, okay. So we tackled these two cases. When product is 0, you do nothing. When product is positive, you take any one element, make it 0, it will become 0. Now, when the product is negative, what does it mean? There are an odd number of negative numbers. Let's say -1 into -3 into -5 into, let's say, 6 into 7. Can I make this product more negative? If this, whatever this is -1 into -3 into -5 into 6 into 7. Can I make this more negative? Let's say it was -1 into 7. Okay, this was the array. So the value is -7. Can I make this -8 or -10 or something like that? Can I do this? No, we can't. Why can't we do this? Because we cannot increase the magnitude of any number. We are only allowed to decrease the magnitude. That is, we can change this in range -1 to 0, and we can change this in range 0 to 7. So since we cannot really increase the magnitude, what do we say? This is the most optimal answer. So if the product is smaller than 0, it's the most optimal. If the product is equal to 0, it is still the most optimal. And if the product is greater than 0, in this case, what do? You take an element and you make it 0. Is this clear, guys? Is this much clear? Is the approach to the first question clear? So let's have a look at the code, right? Right. So I'm taking in input of the array. Then I'm iterating over all elements of the array. If you guys didn't know this, this is a for each loop. Okay. So if I is smaller than 0, I increment negative. If the element is 0, then I increment 0. 0 variable basically counts how many zeros are there. Negative basically counts how many negatives are there. Okay. You could have made it into an if statement also. If AI is smaller than 0, negative plus plus. If AI is equal to 0, 0 plus plus. I am just doing it in one line. This is a very neat trick because this is a Boolean statement. It returns true or false. So if this is true, it will increment 1 or 0. Okay. This is up to you. You could implement this in any way. What it basically counts is number of negatives and number of zeros. So 0 or negative modulo 2 is equal to 1. What does this mean? If there is a 0 in the array, it means that the product is 0. So in that case, I'm going to print 0. Otherwise, if the product is negative, that means that there are odd number of negative elements in the array. So we discussed that in both of these cases, the product is already optimal. We don't need to do anything. So I just print out 0. Otherwise, if the product is positive, that means that there are even number of negatives, right? So in that, I just have to do one operation, right? What operation do I have to do? I can just take any element. This for loop was not really necessary. You just take any particular index and then you print that index and 0. So that is more or less about this problem. Are there any doubts? Is there any doubt in the implementation? Yeah, we can just print 1 and 0. You're right. Okay, great. So moving on to the second question. The second question is a really neat question, and it's kind of beautiful as well. So let's try to understand. You are given a string s of length n. Let's define two operations you can apply on the string. Remove the first character or remove the second character. Now I want to know the number of distinct non-empty strings that can be generated after applying the given operations, right? So let's take an example, right? Let me write A, B, A, B, C. Okay, let's consider this the string. So I want to ask you, like, whenever you are given such a problem, right? So how do you think about it? Like, in this problem, you might think that there are so many ways to make strings, but really, is it so? Yeah. So, okay, many guys thought it is recursion. Some people might have thought it's dynamic programming, but really, is it so? Do you really think that in a div2b they will give dynamic programming or something very complicated? No. So there is a very beautiful observation in this problem. The observation is that what operations can we do? We can either remove the first element or we can remove the second element. Okay. Let's say we are forming a string. Okay. In a string ABC, let's say we are forming a string. What will happen if we fix the first element of the string we are creating? Let's say I'm creating some string and I will say that this is the first element of that string. Okay. The rest can be whatever. What are the possible strings now? Can I have A as a string? I can't, right? Let's see. So I'm fixing this, and this is the first element of the string. Now, what are the operations I have? Either remove the first element or the second element. First element I won't remove because I'm saying that I want this element. Okay. I can remove B. So what string do I get? A, B, C. And this A is fixed. Now what other choice? What is another choice I have? I will do this remove second element once more. I will have A, B, C. I will do this remove second element once more. I will have A, C. And I will do this remove second element once more. I will have the string A. Is there some sort of observation that you guys are finding? Is there? No? Let's discuss what. Now we got this right. Now let's do the same. Okay. What does this mean? This means that for ABC, if we fix the first element, we can have any suffix with it. Basically, I can have A, I can have AC, I can have ABC, I can have ABC, and I can have ABC. Basically, if we fix the first character, I can have any particular suffix with it. Okay. Now, consider this A and consider this A. If I take this particular A, what are the strings that I can make? I can make A, then I can take the first suffix, which is AC, and then I can take the second suffix, which is ABC. But can you see that these three strings I have already made with this particular A? Like whatever strings I can make with this second A, I can also make with the first A. Is this observation coming into your mind? Yes or no, guys? Yeah. Similarly, let's consider this B. With this B, what can I make? I can make B, I can make BC, I can make BC, I can make BA, BC. What can I make with this B? I can make B, I can make BC. Can you again notice that whatever I can make with the second B, I have already made with my first B? Is this observation becoming more and more clear? So what does this tell us? We just need to find the first occurrence of each character. Okay. And if we find the first occurrence of each character, how many strings can I make through it? Let's see. A, B, A, B, C. Okay. Now, if I am on this A, how many strings can I make? I can make only taking A, then 1, 2, 3, 4. Basically, how many elements are in front of it? Plus 1. So that basically boils down, if this index is I, the number of strings that I can make starting from this particular index is n minus I. How did I come across this? Okay. Let's say I am at index I. Okay. How many elements are in front of it? Basically n minus 1 minus I. These are the number of elements in front of it. Here you can see that the string is of length 5 and this index is 0. So 4 minus 0 is 4 and there are 4 characters in front of it. Now I can only take this as well, only take A as well. So the number of strings I can make starting from A is 4 plus 1, which is 5, which is nothing but n minus 1 minus I plus 1, which is n minus I. Okay. Now we keep fixing the first element, and whenever we see a character that we haven't got before, for example, in this ABC, okay, the first occurrence of A is here, the first occurrence of B is here, and the first occurrence of C is here. So in the end, the answer is just summation of n minus I for every I where I is first occurrence of some character. Of some character. Basically, you can see that the first occurrence of A is at 0, the first occurrence of B is at 1, and the first occurrence of C is at 4. So the answer is 5 minus 0 plus 5 minus 1 plus 5 minus 4, which is 5 plus 4 plus 1, which is 10. The answer for this particular test case will be 10. Is there any doubt in this approach? Is there any sort of doubt? Did you not understand anything? But wouldn't there be overlapping strings if we omit A and then omit B? What do you mean by this, Siddhant? Like, what do you mean by overlapping strings? You could unmute and also you could unmute, I guess. Can I unmute? Is it possible to unmute Siddhant? Let me have a look. Yeah. If it is possible to unmute and ask your doubt, that would be great. Okay. Yeah, that's for A. This is a different string, right? So what is the approach? Once again, let's just recap. Basically, we noticed that if there are two characters that are the same and one character is before the other one, whatever strings I can make using this character that start with this character, I can make using this. Basically, in A B C, whatever strings I can make starting at this A, I can also make starting at this A. So I only need to know how many strings I can make for the first occurrence of every character, right? Sure. Can you explain your logic for A, B, C, C, D, D, A again? Sure. So let's consider A, B, C, C, D, D, A, right? So the basic thing to notice is that I'm just going to take maybe D and C's case. Let's consider what strings I can make starting at this particular D. So it is D, it is DA, and it is DDA, right? Now, what are the strings I can make using this D? It is D and it is DA. The thing to notice is that whatever strings I can make using this D, I have already made using this D, right? Because this D and DA I have already made here. So I don't really care about the second occurrence of any character. For example, even in this C, okay? What are the strings I can make using this C? It is C, it is CA, it is CDA, it is CDDA, and it is CCDDA. What are the characters that I can make using, what are the strings I can make using this C? It is again C, CA, CDA, CDDA, and yeah, that's it. So the thing to notice is that these strings that I made using this particular C, I can also make using this C. So whatever strings I make using the second occurrence or third occurrence or fourth occurrence of any character, I have already made them in the first occurrence. That is the basic observation in this problem. So my answer is just summation of ni, n minus I, over all I, such that this I is the first occurrence of some character. Is this clear? Can you tell why this approach links or connects to the two conditions, remove first character or second character? Okay, let me just take it up for a last time. Let's say A, B, 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 C, okay? And we say that we are going to fix this particular character as the first index. So these elements I can remove anyhow. Like, okay, I remove the first character, then I have this string, then I remove the first character again, then I have this string. Now, if I'm saying I am fixing this particular character, I can only do remove second character operations now. That is, I cannot remove this C directly. To remove this C, I have to remove this B. So I remove this B, then I will remove this C, then I will remove this C. Do you get it? That for if I fix a first character, then the only strings that I can make is just concatenation of suffixes, right? Okay. I hope that much was clear, right? Okay. Can it be done using DP? Probably not. And right. So If that much was clear, let's have a look at the implementation. The implementation is very simple. I take in n, I take in string s, and what is this? This array basically stores what is the first occurrence. Like, have I visited that particular character or not? Has A appeared before? Has B appeared before? And it's 26, right? There are 26 elements, A to Z. So here there are 26 elements in the array. My answer is 0, and I iterate through the elements. If I have not found that character yet, what is Si minus A? In ASCII table, A, B, C, D, E, F, G, they are stored consecutively. You can use a map or a set also. I'm just doing this in the most efficient way possible. So that is why I'm using a vector and I'm doing Si minus A. You could have very well used a map or a set to check if a character has been already used or not. So if I have not found a particular character, I say that I have found that character and I add n minus I to my answer. That is all that I do. And in the end, I print answer. Is the implementation clear? Great. Rudra, I will look at your submission, right? But I hope it is okay if I look at the submission at the end of discussion. I hope. Right. Great. So if A is clear and B is clear, let's move on to problem C. What is problem C, right? You have an array of integers a1, a2, an of length n, and on the ith of the next d days, you are going to do exactly one of the following actions. That is, add 1 to each of the first bi elements, okay? Or count the elements that are equal to their position, that is aj is equal to j. Let that count be c. You add c to your score and then reset the entire array to 0, 0, 0, 0. So let's have a look. Let's take an example, right? I'll just write it down and then switch to my tab. 3, 2, 3. Okay. So
This was a
if
really
this is
tricky question.
what happened.
This was a really tricky question.
Yeah, it was. But again, if we just observe one thing, the problem becomes very, very simple. Let's try to understand what that observation is. Now, again, here also we are allowed to do two operations. What operation? Either on the ith day, I add +1 to the first bi elements. Okay. And otherwise, I just count the number of elements such that ai is equal to I or aj is equal to j. I add that many to my answer, and then I reset my array to 0, 0, 0, 0. This is a very important line. Without this line, the problem would have been much more harder. Okay. This particular thing, resetting it to 0, 0, 0 is very important. So now let's see how we use these observations to solve this problem. Let's look at this second operation first. Okay. Let's say my array was 1, 2, 3, 4. Right. Now I do the second operation on it. Right. And now how many positions are there such that aj is equal to j? There are 4 positions. So I add 4 to my answer and then I make this array 0, 0, 0, 0. Now, one thing that you have to notice is no matter how many operations I do after this, okay, whatever the array might be, what if b is, let's say, 1, 2, 3, 4 only, this is b again. Okay. At any instance, there will be at most one element such that aj is equal to j. After this, okay, let's see. The first element is 1. Okay. If I do type 1 operation here, the array will be 1, 0, 0, 0. You can see that here there is only one element such that aj is equal to j. Now let's do the next operation, that is adding 1 in prefix of first two elements. So it will be 2, 1, 0, 0. Here you can see that there are 0 elements such that aj is equal to j. Now let's do the type 1 operation again. So it is 3, 2, 1, 0. So it is, how many elements are there? There is just one element such that aj is equal to j. And let's say there is 4. So the array becomes 4, 3, 2, 1. And again, here there are 0 elements such that aj is equal to j. Now you might ask why? Why is it so that after my array becomes 0, 0, 0, 0? Okay. Why can I have only at most one element such that aj is equal to j? So the basic observation here is, guys, to make this 1, basically I have to make this 1. My goal is to make this 2, goal is to make this 3, goal is to make this 4. So if I want to make this 1, how much do I have to add to this? I have to add 1 to this. Okay. If I have to make this 2, how much do I have to add to this? I have to add 2 to this. If I have to make this 3, how much do I have to add to this? I have to add 3. And if I have to add 4, if I have to make this 4, how much do I have to add to this? I have to add 4. So tell me, guys, if I want to make this element into a 2, can this element ever be 1 or 0? It can't, right? Because we are always adding in prefixes. So consider that it is 2, 0, 0. Basically, if I want to make the second element 2, I would have done at least 2 operations like this, which means that the first element has also become a 2. The property holds that for any sort of operation I do, if I am adding 1 here, I am also adding 1 to all the previous elements. So this array, after it is 0, 0, 0, it will always be sorted in descending order. Is this observation clear? After my array is 0, 0, it will... Oh, you couldn't understand the problem. Okay, okay. Let's understand the problem first and then... My bad. So if you guys couldn't understand the problem, what does this say? That you have an array, okay? And you have d days. And you are given one more array, okay, of size k. And this is of size n. So what are you expected to do here is that you have d days on every day. Let's say on the ith day, on the 0th day, okay, let's consider on the 0th day or the first day, there is some value here, okay, which is smaller than equal to n. This is v1, this is v2, this is v3, this is v4. So on every day you have two choices. What choice do I have? Either add 1 to the first v1 elements of the array. Okay. What does this mean? If I'm on day 1, this will be v1. If I'm on the second day, v2, third day, v3, fourth day, v4, fifth day, again v1. Okay. So I choose the first vi elements. Basically, if this v1 was 3, so I choose the first 3 elements and I add 1 to them. Whatever the value was, I add 1. Okay, and then I move on to the next day. I can do only one operation on a day. I cannot do 2 operations, or I cannot do no operations. I am forced to do one of the 2 operations. Okay, is the type 1 operation clear? How we are supposed to do the type 1 operation? Yes. Now, what is the second type of operation? Count the number of positions such that ai is equal to I. Basically, if this is the first position, is this element 1, is this element 2, is this element 3, so on and so forth. Count how many indices are there such that this is satisfied. Okay, then let's say the count of these elements was C. Basically, if the element is 1, 4, 5, 7, and 5, you can see that there are 2 indices where ai is equal to I, right? The first element is 1, the fifth element is 5. So the count here is 2. So what do? You are told that add that number, add this count. Here it is 2, right? So add 2 to your answer and then make all the elements here 0. This is the question. Now, what does the question say? What is the maximum score you can have? If you had to do this for D days, this is what we are asked, right? So, is the question clear, guys?
Yes. Clear.
Great. So, if the question is clear, getting back to the main observation, once we do a type 2 query, once we do a type 2 operation, my array becomes 0, 0, 0, 0, 0. Okay. Now, I want to make this element 1, this element 2, this element 3, this element 4, this element 5. Let's say I am able to make this element 3. Okay. And this is 0, 0. Let's consider for now. These elements these elements before it can never be 1, 2. Why can't it be 1 or 2 or anything smaller than 3? Because if I am making this element 3, I have done at least 3 operations, right? And if I'm adding 3 ones here, I am by default adding at least 3 ones here and here. Is this much clear? No, applying the first choice doesn't add score to our answer. Yes. If we are always adding prefixes, okay, whatever, just consider these lines. Don't you agree that if I am adding some x in this position to any position before it, I will always be adding greater than equal to x? If after this 0, 0, 0, if I say that the last element is 4, the second last element can never be 3. Because if I have added 1 4 times to this prefix, this value right here is always greater than equal to 4. I hope this much is clear. Okay. Now, if this much is clear, by default, at a particular time, there will be at most one element such that aj is equal to j. Because if I have, for example, it is 0, 0, 0, 0. I say that I want to make this 1 and I want to make this 2. This is never possible because if this is 2, this has to be 2. So at most, there will be only one element such that aj is equal to j. Is this much clear? Like first, for any element, if it is, once we get the array 0, 0, 0, 0, and we make certain amount of type 1 operations, it will always be a descending array, right? And once it is a descending array, because it is a descending array, at any instance, there will be at most one position such that aj is equal to j. Is this much clear, guys? If it is clear, put a yes in the chat.
Yes, it's clear.
Okay. Now, if we can have at most a one position where aj is equal to j, what am I going to do? There is a constraint in the problem that vi is from 1 to n. What does this mean? That if the array is 0, 0, 0, 0, and if I do a type 1 operation on it, the first element will always be 1. Okay. And we said that there will be at most one position. So exactly after doing one type 1 operation, we have that constraint, right? That exactly at one position, I have aj is equal to j. So what is the most optimal thing for me to do? Now I will do a type 2 operation and I will again set it to 0, 0, 0, 0, and I will add 1 to my answer. Again, what will I do? I will do a type 1 operation. This will again become 1 and these are some values. Okay. Then I will again do a type 2 operation. I will add +1 and then this will become 0, 0, 0, 0. For whatever my remaining days are, I will keep alternating between type 1 and type 2 operations. Is this much clear, guys? Clear?
I have a doubt.
Yeah.
What is the role of that infinite sequence that is given in the question?
Uh, the so the basic thing is that we are given d days, right? And on each day we can select some vi. We can't select any vi. For a particular day, it has an assigned vi, right? So let's consider there are 8 days and the array that we are supposed to add of size k is only 4. Let's say this is 3, 4, 7, 8. Okay. So on the first day for type 1 operation, my value is 3. For the second day, it is 4. For the third day, it is 7. For the fourth day, it is 8. So what is the value for the type 1 operation on the fifth day? It is
Oh,
again 3.
okay. It will repeat itself.
Yeah, that is what the infinite sequence means. Like once on the next day, then it will be the first, second, and then when you're again on the last day, it will again be the first one. So getting back to the approach, this is clear, right? Like once I have done a type 2 operation and my array is 0, 0, 0, 0, then I will keep alternating between type 1 and type 2 operations. Okay. Is this much clear? That once I have done a type 2 operation, after that, for how many ever days that are remaining, I will just do a type 1 operation, type 2 operation. Then I'll do a type 1 operation, type 2 operation. Okay. Now, if this much is clear, we only need to know when are we going to do the first type 2 operation. Because we have established that once we have done a type 2 operation, our array is going to be 0, 0, 0, and so on. And after my array has become 0, 0, 0, my most optimal strategy is doing a type 1 operation, then doing a type 2 operation, then doing a type 1 operation, so on and so forth. And on every type 2 operation, I just add +1 to my answer. So I just need to know where is the first type 2 operation that I'm going to perform. Is this much clear?
By first type 2 operation means the index.
Yeah, on which day am I going to perform the first type 2 operation?
Okay.
Okay. Now, I want AI is equal to I. Okay. So what is let's say this AI has some value, like whatever, right? If I add n to this, right, this value will become greater than equal to n. Don't you agree? Like if I do n times a type 1 operation on a particular index, its value will be greater than equal to n. Yes or no?
Yeah, makes sense.
Right. So the first type 2 operation that I'm going to do, it is not going to be infinitely away. Like it is going to be after at most n operations or 2n operations, right? Like for example, if my array is 1, 2, 3, 4, consider this. If 4 times I do a type 1 operation and all the values are 1 to 4, then after I do 4 times the type 1 operation, this will become 5, 6, 7, 8. All my values are greater than equal to n. So does it make sense for me to do more than some amount of operations, type 1 operations? I am bounded, right? I cannot do unlimited number of type 1 operations and then do a type 2 operation. Does it make sense?
But we have to do it only until D days, na?
Yeah. So minimum of d comma 2n days is the bound. Like that is the maximum number of type 1 operations you are going to do before the first type 2 operation. Is that much clear? Like I have d days, okay, and I want to find where is the first type 2 operation I'm going to do. Now the thing is, I am not going to do unlimited number of type 1 operations. It's bounded by 2n. Like I won't be doing more than 2n type 1 operations. Otherwise, it won't make sense. Like my values will become more than n and then it'll always be 0. Right? So why 2n, you ask? Okay, how 2n? Let's try to understand how do we come up with this 2n. Or like you might think that maybe it is n square or so on and so forth. So why 2n? Yeah. So why 2n and not n? Even me during the contest, I thought that it would have been n. And my first submission was n. But it is not actually n. And let's try to understand why. Okay. Now let's take an array where let's say it is 0 and 1, 2, 3, 4, 5. Okay. Now these values are between 0 to n. Okay. So let's assume that all of these values are smaller than n, smaller than that particular index. Only then if we add, it will make sense, right? So this is 0, 1, 2, 3, 4, 5. These are or 0, 1, 2, 3, 4, 5, whatever. So I need to add 1 to this. I need to add 1 to this. I need to add 1 to this. I need to add 1 to this, to add 1 to this, and I need to add 1 to this. But it could have been 0 here, 0 here, 0 here, 0 here, and 0 here as well. So at most, I have to add 2 and minimum 1. At most, I have to add 3 here, 4 here, 5 here, and 6 here. Okay. Now, the thing is that let's say till this particular index, I made some operations. Okay. The array is, let's take a particular example. I think that would be much more better. Let's
I
take
think last example.
what?
Last example.
Okay, 1, 2, 3 and 1, 3, 2, 3. But
Yeah.
there already 1, 2, 3 satisfies the conditions, right?
Yeah.
So it would be day 0 only, right?
Let's try a second.
Yeah, um let's try the second example. Okay, 1, 2, 4, 1, 5, 6 and 6, 6. Okay. So now if I do one operation of 6 here, these elements will become 7, 2, 3, 5, 2, 6. Okay. Now you can see that there are two elements that are satisfying this particular condition. If I do this operation again, right? And let's say this is the first element which is satisfying this condition. The elements here are going to be greater than equal to that number. So it won't be satisfying that condition. If all Vi are 1, yes, we can take that condition also where all Vi are 1. In that case, this would have been 0 or whatever. Let's consider 0, 0, 0, 0 only. And here it is 1, 1, 1, 1, so on and so forth. So if all Vi are 1, you are only going to do this operation, right? You're only going to add 1 here. So if you just make this 1, 0, 0, 0, then 2, 0, 0, 0, 3, 0, 0, 0, so on and so forth. So it doesn't really make sense, like unless this is 0, you do a one type 1 operation, otherwise you would just do a type 2 operation and continue. But like I'll get back with a formal proof in some time. But the basic thing is that after doing approximately 2n operations, okay, like you wouldn't really require to do more T1 operations. Like this number is bounded by 2n. I'll share the formal proof with it, but the basic idea goes that the numbers are bounded up to n. Like for each I can only have that number smaller than equal to AI. I want it to be AI, right? So if I do more than 2n operations or more than n plus something operations, this 2n is a very loose bound. Maybe it is n plus 1 or n plus 2. I'm not quite sure right now. You won't really need to do any more type 1 operations. Like the answer will be always 0 after that. Like it's pretty much useless, right? So if this much is clear, right? If 2n comma d is clear, like we would have to do the first 2n comma d at most. We would have to do at most the first 2n comma d type 1 operations, and then we can do a trick. That is, our array becomes 0, 0, 0, 0. Then I do a type 1 operation, then a type 2 operation, then a type 1 operation, and a type 2 operation. Is this much clear? Yeah, if we do it for more than 2n operations, then we can get max answer n by just doing 2, 1, 2, 1, 2, 1. So the max we only need to check till 2n. Yeah, makes sense. Right? So this is our solution. Okay. What is our solution? We need to check when is the first type 2 operation we are going to do. Okay. And this type 2 operation is in between day 1 to day 2n. And you might say that day 2n might be greater than d and we only have d days. So it is minimum of 2n comma d days. my first type 2 operation is going to be in this particular time segment. And once I have done my first type 2 operation, let's say it is the kth day. Okay. Now for the next d minus k days, I am just going to do a type 1 operation, then a type 2 operation, type 1, type 2 operation. And in that particular case, like for my remaining d minus k days, on every 2 days, I add a +1 to my answer. So I will be adding d minus k by 2 to my answer if on the kth day, I decide to do my first type 2 operation. Now, the rest is just writing a brute force. We check for every day from day 1 to day 2n on when is the first type 2 operation we are going to do. Is this much clear, guys? If it's clear, please say yes. Yeah. So let's have a look at the code and try to understand why this works, right? So I have an integer n, then I have an integer m, and I have an integer k. I am taking in my input, right? Then what did we discuss? We discussed that we have to find the first day when we are going to do the type 2 operation. Okay. Here I'm using 0-based indexing. I could have used 1-based indexing as well. It doesn't matter. So first, if I am going to do a type 2 operation on this particular day, I need to find how many AIs are equal to I, right? Like what is the particular C that I'm going to add to my answer. So I've written a function for that. You can use, so this is how you can write a function very easily. So you can write auto find equal to, then you open square brackets, put an ampersand in it, and you pass in a vector because I want to count how many AI is equal to I in that particular vector. So I count the number of indices where AI is equal to I. This is 0-based indexing. That is why AI is equal to I plus 1. And then I return count. So if I'm doing type 2 operation on that day, then I find how many are equal. So what is my answer if I do a type 2 operation on that day? It is how many are equal before, like doing, if I'm doing it on day k, if I do type 1 operations on k minus 1 days, how many are equal? And after that, it's just d minus k divided by 2, right? If there are, so k is the variable that I've taken. So there are k days. And on the I plus 1th day, I decide to do a type 2 operation. So my array after that becomes 0, 0, 0, 0. So for the every second day after that, I add +1 to my answer. That is why whatever whatever number of equal elements I had before doing the type 2 operation, I add that. And then after doing the type 2 operation, it's just type 1, type 2, type 1, type 2. Okay. Now, once I have calculated this, I say that, okay, I'm not doing a type 2 operation here, which means that I'm doing a type 1 operation. So if I'm doing a type 1 operation, I just update my answer, right? Because first I calculate type 2 for day 1, then I calculate type 2 for day 2. So if I'm calculating type 2 for day 2, first I need to update that type 1 for day 1. So I just call the update function for I modulo m. I modulo m is basically the index of the array B, basically the value which we have to increment. For example, if we look at the problem statement, on the first day here, I will be adding 1. On the second day, 3. On the third day, 2. On the fourth day, 3. On the fifth day, 1 again, right? So what is this? It is 0 modulo 4, 1 modulo 4, 2 modulo 4, 3 modulo 4, and then again 0 modulo 4. So if I'm on day I modulo I modulo K is basically the index of B which I'm on. Basically that prefix I have to add. So I just pass in that particular index of array B which I have to take in. And then for that particular prefix from index 0 to index B of index, I just add one to each element that there is. That is more or less to this question. Implementation is not that tough, but thinking around like we have minimum of 2n comma k elements, and then for each element, for each index, you have to count. Like if this is the day where I'm doing the type 2 operation, then before all this, I was doing only type 1 operations. So the answer for that, plus after this day, I'm only going to do type 1, type 2, type 1, type 2. So there are two elements to the question, and in the end, you just print answer. So is the solution clear, guys? Yeah, this is O of n square. True. N is smaller than equal to 2000. So you can have it in O of n square or O of n square versions. I hope this solution is clear. Do you guys have any other doubts? I think we'll stop recording. And after that, if you have any other doubts, you can just ask it to me right now. Just stop recording.